Welcome to this video. This is our fourth review session for AP Stats Final Review, and today we're gonna focus on probability, basically the contents of Unit 4. And whatever you're preparing for your AP exam in May or other tests or finals, I hope this video helps. So let's jump right in. Basic concepts: outcome, sample space. What is sample space? It is set of all possible outcomes. So for example, if I flip a coin, then the only two outcomes I'm gonna get is tails or head. The event and complement. Complement, there are a couple ways you can represent it using symbols. So for example, A to the C on the top and A prime. Also, there's a way with A, there's a dot on top of it. But those are all mean the same thing, complement. So complement representing using formula just means if you want to get a probability of a complement, then you're going to use 1 minus the probability of non-complement. So probability of A, if we want to try to find the probability of complement of A. So they're opposites. Probability of an event, remember that will always be in between 0 and 1. It can be 0 and it can be 1. If it's in those two extreme cases, that means it's either gonna 100% occur or it's never gonna occur. But most of the cases, they will lie between these two numbers, and it can never exceed 1 or be negative. A theoretical probability is and empirical probabilities. Like theoretical probabilities, we're gonna use the formula to help find out. Empirical probability is based on observation. Law of large numbers is more is better. So just think about, like, the more you flip a coin, the more the outcomes, the percentage of getting tails and heads will become 50%, right? Because that's going to be closer to the true probability. So more is better. Random variable just means event as a number. So we're gonna numerically identify the outcomes of our event as numbers. Probability distributions, basically you're gonna list X or number of heads. We're still using the coin flip as our example. So we're gonna use 0, 1, 2, 3, 4. Actually, it's not flip coin, because flip coin you only have two outcomes. Okay, sorry, I can't remember what example we used right here, but just as in reference, okay? So those are the type of events that are gonna occur, or type of outcomes, and next to them we're gonna list the probability of those. So moving on to calculating probabilities. Independent events, if we are trying to find, for example, probability of A and B, then if A and B are independent to each other, which means they are not going to affect to each other, right? Their outcomes won't impact to others' outcome. Then we're simply just multiply them together. If they're dependent, then we're gonna use probability of A times probability of B given A. This straight bar right here means given. Disjoint events, also known as mutually exclusive. So what is that? It means that I remember the video that I taught in one of my playlists. I just said, like, imagine that you and another person, you hate each other. Like, you and that person hate each other. So, which means that whenever occasions you occurred, he or she will not occur, and same vice versa. So that's, I think, a little good example for how you remember the definition for disjoint events. And whenever that occurs, probability of A and B is equal to probability of A given B and probability of B given A. Those three probabilities will always be 0, because you and he or she cannot occur at the same time. Never, ever. Addition rule for disjoint events is going to be probability of A or B. Probability of A plus probability of B is going to be equal to this value. Addition rule for non-disjoint events is probability of A or B equal to probability of A minus, this should be plus, sorry. This is like a typo right here, but it should be plus. Probability of A plus probability of B minus probability of B A and B. So that makes sense, right? Because if B and A can never occur at the same time, which means the probability of A and B will always equal to 0, then if we want to find the probability of A or B, we don't have to care about that N component because it will always be 0, so no change in the value. And remember that all of the probability adding up together will be 1, and this is the summation notation, which just means adding all of the components together. For multiplication rule, there are also two cases, independent events and dependent events. For independent events, it's the same formula that were used in the first example, probability of A and B is equal to probability of A times B. Probability of A times probability of B. For dependent events, it's probability of A and B equal to probability of A times probability of B given A. And moving on to conditional probability. This is a huge part for Unit 4. And this is where probability of A given B is equal to probability of A and B over probability of B. So whenever the component that is it's in the back, so it's in the back of this given symbol, it's the probability that we're going to put in the denominator. So don't confuse with that. And this is also on your formula sheet or your packet when you actually enter the AP exam, so don't worry if you cannot remember it. Also, there's tree diagrams. So I have a lot of good examples that I talked over in Unit 4 playlist, so feel free to check that out. I won't go deep in this video, but you can always go deeper review for yourself. For probability distributions, mean and expected values were represented as this. E just shorthand for expected. And it's equal to the mu sub x, which just means the mean, right? And how are we going to calculate by hand is we are going to find the summation of x times the probability of x for each values. And for standard deviation, it's known as standard deviation sub x is equal to the summation of square root of x minus the expected value, quantity squared over n minus 1. And you know what? Most of the cases, AP Stats exam won't ask you to do standard deviation by hand. You will be very likely to met a problem that using this formula to calculate mean, but you will never show work for standard deviation. So nice thing about that is that you're just going to use your calculator, putting the values into L1 and L2 and get the standard deviation for this. How nice it is, right? And moving on to normal probabilities, we're going to use empirical rule or use z-table, or we're going to use normal CDF and inverse norm. And those two are the most important method that you're going to be master. Because you're going to use it a lot on your calculator, and how nice it is, the calculator just gives you all of the messy values for you. Also, binomial probability and geometric probability are another big concept. There are a lot of big concepts in Unit 4. I know it's a big unit. It also plays a huge chunk of questions on your exam, so just make sure you review that very hard. And what are some prerequisite for binomial probabilities? Well, first of all, it's either going to be success or failure. There's not a third option for you. And it's same thing for geometric probabilities. For the second rule, it's probability of success is same in each trial. So same thing applies for geometric. Trials are independent. Same thing for geometric. And the fourth condition, it's different. For binomial is the fixed number of trials, or how many successes. So basically that you're going to have a fixed number of trials for how many successes you will get. While on the other hand, for geometric, you will go until first success. So see the difference between these two. Geometric is like you go all the way till you hit the first success. Well, when is the first success? We don't know. Or sometimes the question will asking you, well, what is the probability of getting the fifth trial as my first success. You're gonna go into your calculator and do all of that stuff. But for binomial, you will never encounter that type of question. And that's also a hint. If the question gives you until what like first success or not, then you're gonna use geometric. Otherwise, it's binomial. And for mean and standard deviation for these two, for binomial, the mean, you're gonna use n times p. For standard deviation is square root of npq. Q is 1 minus p. Mean for geometric is 1 over p. Standard deviation is square root of q, or 1 minus p over p squared. And PDF and CDF. So PDF is probability of x equal to an exact number, while CDF is probability of x less than or equal to that number. So imagine CDF as a like some bound that you can never go exceed that. So that's the maximum value that you will get. Therefore, all of your other values is going to be less than or equal to that. Well, for PDF, it's just what is the probability of getting that exact value. So notice the difference. And simulations, we already touched that on last video, which is in Unit 3 review session. Feel free to check that out. And I also include this simulation in, I believe it's in Unit 4 playlist. So sorry about that, like AP Stats, they manipulate the simulation quite often in every year. Sometimes they put it into Unit 3, sometimes they put it into Unit 4. It really depends on what year you're testing. But the concept or knowledge are all the same, so feel free to check that out. And basically simulating probabilities and wait time simulation, yeah, just go into my playlist. And yeah, I hope this video helps. And yeah, again, like this is a quick review, I know, but the purpose of this video is just help you to have a general picture of how this Unit 4 looks like and what are some key components you're gonna be focused on when you're doing your self-review. So again, I hope this helps. Thank you so much for watching. More content, stay tuned.